Start streaming.
Wait, I don't want to miss this.
Oh, okay. I think it's working.
Yeah.
All right. Can we watch the live streaming now? Let's see. Does it work? Go onto the thing and see.
Yeah.
Okay. How fancy is that? It's like my dream that someday
You'll become famous.
No, that someday, like, instead of the kids doing stuff in all their other classes, that they're watching chemistry in this class all day, every day. Because chemistry is just the best thing ever. So
There's 3 people watching.
there's already 3 people watching. That's special.
Yeah.
All right. But no, I really do want to start getting over this. So, again, we got other stuff. Okay. You're going to need to go to page SP23. All right, Empirical Formula of Hydrates. Yep. This is just a test to see if it works. Okay. The way this will work, so when we talk about something called a hydrate, it's a little bit different than what you traditionally would think of a chemical compound to be. Hydrates involve having not just a compound, but also some waters bonded to that compound. Let me shut the door so we don't have to listen to people in the hallway. Now, I'll show you guys a picture here. The live stream can wait. You guys can actually look at a picture of this.
Wait, the live stream?
The live stream's still going, but no, I actually wanted to show this to you. One of these days, I'll figure out how to set it up where I can show everything really fancily, but that's not happening just yet. But copper sulfate, it's actually pretty cool. It's something we're gonna do a lab with a little bit later. And so if you take a look at this stuff, like this crystal right here, it looks pretty neat, right? So it's this nice bright blue crystal, and what it is, it's actually a mixture of. Really? We just shut the door. Somebody wants to go. So what this blue crystal is, it's a mixture of copper sulfate and water. And there's some random amount of waters in this crystal. Now when we say it's a hydrate, what we mean is this. It's a solid with some waters bonded to it. But does that look like does it look watery? I mean, it's a solid crystal. Inside here, forming in like the crystalline structure of it, the water molecules, they're bonded together as a solid. However, what you can do, you actually, if you heat this up, if you crunch it up, grind it up, and then heat it up, it'll actually, all the water will evaporate, it'll turn nice and gray, which is, we're going to do that in a lab next week, so that'll be fun. But the point is, there are a bunch of chemical compounds that exist, basically, that show that you have a solid compound with waters bonded to it in a crystalline structure. Now, how does this matter to us for empirical formulas? Well, what it does, it simply means that, what? You can hear me on the thing?
No, I'm reading the comments.
Oh, there. All you people already. Yes. I can look at them too.
Yeah, please do.
No, here, bring it up on a computer so I can see it too. If anybody writes anything inappropriate, I can fail you.
Oh, no.
Oh, no, not at all.
Oh, I don't care. No, it's lovely.
No.
Why not?
I don't trust that many people. But no, but really, so the way this works with the whole hydrate thing, it's cool. Like we'll grind this up. Have any people ever used a mortar and pestle before? Like it's one of those things where you grind spices up, I think, traditionally. We're gonna do that with this. We'll grind it up, it gets really fine, like a powdery thing. And I'm gonna have to shut it down, people are ruining it.
No, people.
Then pay attention. Okay. Stop typing stupid comments. Just come on.
It's just not something that you're going to tell.
Oh,
Other classes are actually watching.
Really?
Yeah, there's a
That's funny. Anyway, so what I want to actually show you is how to do empirical formula calculations, figuring this out. So in short, here's how this works. You're going to have, actually, can we pay attention now?
Yeah.
Okay. So the way it's going to work, for copper sulfate,
Yeah.
we don't need to hear it. You can hear me. You're there. You're actually at the event.
Wow, that's great.
You're one of the special people that are actually at the event, not watching it on the live stream.
It was behind. The thing is behind.
So why is it behind? Because it's got to go through here, be processed by the computer, uploaded, processed by YouTube, then sent out to your phone. That
It's
takes a
like
little
really
bit.
Behind. Oh wait, it's like
It's behind
I can hear it right now.
I'm so scared.
Who's
I can hear.
I don't
Whitney.
even know who
Whitney's
these
not
people
talking.
are.
Hello, me. No,
Hello,
he
hi,
literally
I'm
what you
here.
just said.
Oh, she's gonna watch. Oh, that's why we're doing this. She can watch this. Who?
Austin and Claire.
Oh, that's cute. They're gonna learn chemistry. That's nice. Okay. So anyway, the idea here is that basically the problems, you're going to write a formula out like this. So like what we're going to do for this problem, basically we're going to have something like copper sulfate, CuSO4. Does that show up decently well up there with the camera? Like, I mean, does it look okay? All right. Now, the way it works, it's bonded to some amount of waters, okay? And what we're going to do, we're going to figure out what number basically goes in that spot, which is saying how many water molecules are bonded to one copper sulfate formula unit. Now, this is how you write, this is just how you write it out. You write like whatever chemical you have, then you write a dot, like a multiplication dot, then you would have a coefficient in front of water indicating how many water molecules there are. So to give you like the, well, you know, we'll do the problem, then I'll draw it, the structure out a little bit. So the problem starts, it says you've got a 5-gram sample of hydrated copper sulfate. So the way this sort of works out, right now it's telling you have 5 grams. And you'll notice, by the way, this problem, this is kind of a long problem, isn't it? It's like a paragraph-ish. There's a lot of stuff. That's how we're going to be moving in this class now. The problems are going to be longer. They're going to be a lot more involved. You know, they go from being like just convert grams to moles to like, okay, now convert grams to moles and then figure all the stuff out. Okay, so there's a lot more to it. Let's see here.
We're talking about your mom out there.
Can we just, oh yeah, you're famous. You're at the event now. Yeah. Yeah. No, you can't come in. So, no. Yeah, on YouTube. Sure, you'll find it. Twitter. Okay. Go away. He'll figure it out. I gotta be nice because the camera, you know. But no, so the way it's gonna work, you've got your 5-gram sample, and when it says hydrated, this actually matters now. Because what does hydrated mean? Does that mean that water is present? So this word, hydrated. Can you even see, like, can you see that? Is that big enough up there for you guys to even see? Okay. Yeah, all right. Oh, okay. But the whole, the 5-gram thing of hydrated, does that mean water's present or not present? Hydrated means there's water present in the chemical. So what this initial means here, this is the copper sulfate plus the water. All right. Now it says it's heated until all the water was driven off. It says after heating, the remaining 3.19 gram sample contained a bunch of other stuff. It says it contained 1.27 grams of copper, 0.64 grams of sulfur, and a bunch of other stuff. But first, pay attention, important. But first, what that means, after heating, all the water's gone, right? So all this stuff, this is copper sulfate plus water, and then it breaks it down for you and says you have 1.27 grams of copper after you heat it up, 0.64 grams of sulfur, 1.28 grams of oxygen, and you're kind of not told what the water is though, right? So how could we figure out water here? What do you think we could do? Like if we know that our 5 grams is copper sulfate plus water, and we're also told here that we have 3.19 grams after heating, all right, that's just going to be the copper sulfate. So can you envision a scenario in which you would calculate the water here? Would you do 5 grams minus 3.19 grams? You probably would, right? That's equal to 1.81 grams, and that's the mass of your water. All right, that is the mass of your water. So, now, empirical formula. If you think about the empirical formula stuff, the idea is there were 3 steps, right? So step 1, let's see how this is going to. So step 1 is convert to moles for everything. So this is also a review of yesterday. So you're going to convert to moles. What are you going to convert to moles, though? Well, you've got 4 values. All right, you've got 4 values that are grams right here. You've got copper, sulfur, oxygen, and water. You're going to convert all 4 of those values directly to moles. Okay, all 4 of them. So that's what you're going to do. In these problems, notice it's a lot, but if you actually look at the assignment, there's only 3 problems that you're going to even be assigned here. So you're going to convert to moles. All right. Now to do this, just wonderful bells. So you're going to do 1.27 grams of copper, and then you'll do moles of copper. So 1 mole is equal, and just as a reminder, if you're still not sure where these numbers are coming from, 63.55, right? Do we acknowledge that's where it's coming from off the periodic table because it's copper? So that's 63.55. You're going to do the same thing for each of these. What? So for this one, like I said, I would generally suggest that you use 4 digits after the decimal place. Like I would go to the 10,000ths place for rounding. It just generally will lead to it being a little clearer in terms of what the ratio is. So 1 mole here is 32.07 for sulfur, and then you'll do the same thing for oxygen. So you'll do 1.28 grams of oxygen, So this is 1 mole, 16. I mean, hopefully this is just purely review. The only thing that might be a little weird is that notice what I'm going to do with water here. So water is 1.81 grams of H2O, right? It's H2O. It's got H and O in it. We're not going to separate that. This is actually something that does kind of catch people sometimes. You're going to keep water like together. So when we divide and convert to moles of H2O, we're going to treat it like it's just one, like it's a molecule. We're not breaking it apart. So grams of H2O, moles of H2O, and that is 18.02. All right. Now, you can't look that up on the periodic table, just as a reminder, so you really are going to do, you got 2 H's, you got 1 O, it's 1.01, it's 16. So to be clear, where this number is coming from is the sum of H, 2 H's and 1 O, just to be clear. Then you're going to do the math, and you're going to divide and figure out what all of these are equal to. So let's do that. Now, for the sake of time and calculator, I'm pretty sure I know what these are. I think it's 0.02 moles of copper. Moles of sulfur. You're all being utterly silent. How special. If anybody has a question, please ask too. Like, please, seriously, don't worry about the thing. Just ask. Oh, there's so many people. Oh, did you hear that on the stream? All right, and then oxygen is 0.08. 0 moles, and then we've got our water, which is 0.100 moles. So the first thing that you're going to notice, there's a lot of these things. Don't goof them up. Like, make sure you label copper, sulfur, oxygen, water. Keep them straight. It's really hard to, if you don't label them, it just doesn't work out. Don't goof that up. All right, so once you do this, once you see this, all right, next step. The next thing you want to do is, okay, we converted to moles. Now, what is step 2?
Divide.
So, divide by smallest. Which thing is smallest here?
0.020.
Are we all confident that it's 0.02?
Yeah.
Do some of us think it's 0.1? And some people do because they're like, oh, one's smaller than 2, but like look at where the stuff is. Look at where the decimal points are and stuff. So obviously 0.02 is the smallest. Now these are the same, so that's fine. So just divide all of them just by 0.02. So divide everything by 0.02. All right, so for copper that will equal 1. For sulfur, that will equal 1. For oxygen, that will equal 4. And then for water, what will that equal? 5. Yeah, 5. This is really showing up okay?
Mr. Red.
What?
How much are 2 wrong? Like, what out of 15?
What?
If they got 2 wrong, how much out of 15 would that be?
I'll explain. So, okay. Now, we're pretty much done with the problem at this point because all you're going to do now is step 3, which is just write your formula. The only thing, so now with step 3, just, write the formula. You'll just say, okay, we've got 1 copper, 1 sulfur, 4 oxygens. Now, I will acknowledge some of you, like if I hadn't shown you the formula already, you might not think to write it as like CuSO4 in that specific order. It kind of requires you to think back to like how ionic compounds are written, like when you do the other couple problems. You're going to need to sort of remember like, okay, the cation, the positive thing, copper is written first, then sulfur and SO4, that's going to be a polyatomic ion. It's a negative anion, so it'll be second. Or, I know some of that is like, that's a lot. The other thing you could think of is just like, look at the problem. You see how copper is first, sulfur second, oxygen's third. If you're not sure, just write it in the order the problem gives it to you. That'll almost always work out. So you write CuSO4. Then you're going to write a little dot, and then you're going to put 5H2O, and that's your actual empirical formula of a hydrate.
Why'd you put 5 in the front line?
Because so that's how you're going to write the hydrate formulas out. This number right here is pretty much always what you're calculating. All right, what that 5 is or whatever it might be. All right. And what we'll do in a lab next week, like I said, you're going to grind up that blue crystal, and you're going to heat it up a lot, and you're going to basically, yes, I just said you're going to grind up the blue crystal out. It's so funny. But you're going to grind that up, and then you'll heat it up, and you'll cook off all the water, and then you're going to basically see how close you can get to this number. The more accurate you are, the closer you'll be to the number. I mean, you'll see how right you are. We actually got new copper sulfate this year too, so it should give us really good results. I'm actually kind of excited about doing it. Anyway, and that's your formula. That's it. Like this really is the kind of the point of everything. Is like how many waters are there in the formula? I mean, that's pretty much all you're doing. And that's it. So like, what questions do you have on this? Nothing? Anything? Which what do you mean?
Scroll up a little.
Like that?
Yeah.
Okay.
No.
What?
Why did you divide by 0.02?
So, all right, why do we divide by 0.02? So you look at all these values, right? Did you understand how we converted to moles for everything? Okay. Will somebody let Nora in? She's at the door, and she's just going to keep knocking. But once you divide it and you got 0.02, 0.02, 0.08, 0.1, you got to say which number's smaller. Out of all the ones you get from dividing, no, that's it. Just out of all the ones you get from dividing, whichever one's smaller, just go with that. And divide everything by that number. What?
So if you get a decimal for one of them, do you have to?
So now, if we had gotten like 1 and then like 1.5 or something, yeah, you would have doubled everything to make it a whole number still. Like that whole number thing, that still applies to everything you have to do. That's just, how do you know? It's just, you got to just, whatever it takes to make it the smallest whole number that you can get it to be. It's just sort of, like I was saying, like if you have.
So like it doesn't need to be a whole number, it can just be the smallest one?
The smallest whole number you can make it. So like you'll just have to do the math and figure out like, if it's like 1.5, you double it. If it's like 1.25, you multiply it by 4. If it's like 1.2, multiply it by 5. Yeah, I mean, that's just how it would be. So, okay, questions, anything? I'm going to turn this off now because I think we've had enough. So, let's click buttons.
Click on some payment for your shoe.
Goodbye, everybody.
No, you should keep